Okay, so what we need to do is kind of set up a skeleton that we can work with for this function. So we're going to have a y on this side, and that equals, I think I used a in the notes, some books use k, but I'll use a as my constant. And then we're going to figure out, and what this a is going to do, it's going to give us our stretch, it's also going to give us our sign. If we do everything right, this one should come out to be negative, and then it should be an even power when we add all of them up, probably degree 4, because I think we're doing least degree, because that would be a negative even, and it's opening down like negative x squared. So let's go through each of these intercepts. So if negative 2 is a 0, that means I have a factor of x plus 2, and that would be to the first if we're doing only 1s and 2s in terms of our power, so least degree. But we'd have to have a factor of x plus 2 to give us the 0 at negative 2. Likewise, I'll have to have a factor of x plus 1, right, to give me that 0 at negative 1. And then this one, if you notice, it's bouncing. So that means it's an even degree and even power, so it's going to be squared. I think when I looked at the answer, it wrote them out side by side. I prefer to write it as a squared because it calls attention to the fact that that should bounce and each of these should cross. So that's the basic shape of this thing. This a is going to, like I said, is going to have to come out negative to have it open down. And then beyond that, we're trying to figure out why these points are exactly where they are. What number do I put here so that it comes out exactly like this, rather than maybe say it has all these same intercepts, but what if this went way, way up, and then this came down, and then bounced again? Or maybe it was really compressed and this barely cleared and bounced. So that's what that a does, is it's your stretch factor. And the way that we can find that is, if you notice, we have 3 variables up here. We have x, y, and a. And so I know this contains the point, and it's not one of these zeros, so I can use it. Otherwise, it would just come out 0 equals 0. But I know that this function contains the point 0, negative 3. And so I will put that in for my x and my y, which makes a great x because it makes all these really easy. So it's nice if we have the y-intercept. I'll put those in for x and y, and that's going to let me solve for a. So y is going to come out to negative 3 when all these x's are 0. So that would make 2 times 1. And then this is negative 1 squared, so negative 1 times negative 1 would make 1. So negative 3 equals 2a. And then dividing that over, a equals negative 3 halves. So then our answer will be y equals negative 3 halves, x plus 2, x plus 1, and x minus 1 squared. And again, that fits with what we should see. It should be a negative, and it should be to the 4th, because it says 1, 2, 3 turning points, so it has to be at least to the 4th. That's pretty much how you do those. And this is good to get down, because when we get to I think it's the next chapter, we'll do this same thing a few more times, where we have a graph, and then we kind of build a skeleton for it from what we know, and then we solve for that stretch factor in front. So we'll use this idea on a couple other kinds of pictures.